Consider the K-map given below, where X represents don't care and blank represents 0. Assume for all inputs A, B, C, D, the respective complements A complement, B complement, C complement, D complement are also available. The above logic is implemented with 2 input NOR gates only. The minimum number of gates required is dash. So this is a question from K-maps from digital logic. Now K-maps are used to find the minimum product of sum or sum of product forms of a given expression. So we have been given the K-map for this expression. We need to find the minimum sum of product form of this expression, and then to represent that expression how many 2 input NOR gates are required. That's what we need to find here. So we'll try to minimize this. So we need to find the largest prime implicance here. So if you see 1 and 1, we can couple these 2 together, but if you look to the left side of it, you will see that there is X and 1 as well. X is don't care term. X can be 0 or 1. So we can combine these 4 together into one group. So this is the largest one. To the top or down we have zeros only, so we can't take those to combine. Now if you look here, these are also don't care terms. We can combine these together. We can combine these 4 to form one expression, but it's a don't care term. If we just give 0, we will be eliminating just one prime implicant altogether. So we don't need to do that. We can equate these X to 0 and ignore those. So this is the minimum sum of product form of this K-map. Now we will find out what this actually is. If you look, the variable B changes from 0 to 1 here, so B is not the one which we have to take here. A remains constant at 0 to 0, so we can write A complement. Now here D changes from 0 to 1, so D is not the one. C is constant, C is 1, so we can write C. So what I have drawn here, these 4 together, this is AC. Now in the question they have asked 2 input NOR gates. What NOR gates do is, when we input A and B, it will take A plus B the whole complement. So if we can write it as A plus B the whole complement form, if you look, using De Morgan's law we can apply, and we can write it as A plus C complement the whole complement. A plus C complement the whole complement is A complement into C complement complement, that is A complement C. So we can write it like this. This is what we can express using just one NOR gate. A and C complement input, we will get that. In the question it was given complement forms are also available. That's why we could do it using just one gate. So the answer is 1.